Alright, so I'm tearing down the motor on my side-by-side again and get in here trying to get the stator off so that I can change out the timing chains and the oil pump drive chain there. And I don't have a puller. It's only a $16 piece that I can order off Amazon, but I've got the day off and Sarah's having to work, so I'm gonna try to make one, see what happens. Okay, so I measured it here. Looks like it's pretty close. I'm assuming it's metric. This is a Polaris. Looks like it's pretty close to a nominal size of 50 millimeters. And then the pitch gauge here tells me that it's got the thread pitch of 1.5. So we'll make one of those and see if it fits. And it's left-handed threads. I have to remember that. That makes setting the lathe up a little funny. Alright, so I got a piece of mystery metal in here. Come off some kind of a shaft or something or other I picked up. I'm gonna start whittling on it a little bit. I'll clean up the outside just because that's usually the first thing I do. And then I'm gonna square this end off, and then I'll bore me a counter bore in here to the root diameter of the 50 millimeter thread. I'll have to look that up. I got a chart somewhere. Alright, so I got that done. Now I'm going to go in here and just start me a hole with a center drill here. I'm going to speed this thing up. These center drills like to run fast to the middle. And it's easy to break one. Hard to get them out after you break them off though. So I'm going to go in with just a 1/2 inch for my first starter hole here. I need it to be about, the counter bore to be about 40 millimeters deep or so. It's very hard for me to think in metric, and I struggle with the conversions. So I measured this out and I put me a red mark on my drill bit. This is not a critical dimension. I just got to have deep enough to get over the snout of the crankshaft. And my lathe is marked off in inches, but like I said, I'm horrible with that, and I think in inches. So we'll poke a hole here and see what happens. Sharp bit. test it, make sure I got enough room in there. All right, so switched over to one of my big bits here. I've only got a handful of them, but I need a 48.5 millimeter bore, final bore. This is like a 44 millimeter bit. It's standard, but it's pretty close to that. And then I'll finish boring it with a boring bar to size. This just lets me remove a whole lot of material pretty fast here. This lathe's got plenty of horsepower, so let's see if we can take it. Yeah, got a little chatter there. I'm gonna slow it down some. Let's see if that's any better. That's a chip there, bud. Start breaking them chips. If they get too long, they can hang up and whirl around here, and those are very hot and sharp, so I try not to get hit by them. Alrighty, let's stop and get this cleaned up. These things are, big old chips are horrible. Alright, so I've got my boring bar set up here. Little cheap magnetic back Chinese indicator. Just set up so that when my carriage comes back, it's going to hit this, and then I can stop my carriage before I get to zero and then manually feed to zero. That way I don't crash my tool into the counter bore, the step that's inside this. And then I made a real light cleanup pass to zero my dial here, and then I did the conversion on that. I need this to be about 1.91 inches inside, and then I switched over to these dial calipers here. I don't trust the digital ones very much. The calipers aren't precision anyway, but these are light years ahead of the digital ones. The digital ones will make you ruin parts if you're not careful. And these are duals, which is pretty neat. They make band saws and all kinds of equipment. Pretty good company, used to be anyway. Looks like these are made in Germany. I've had these. I picked these up at like a flea market, which is where I get a lot of my measuring tools from. But these have been pretty good through the years. They're pretty tough, and they're kind of my beater calipers that I keep on the lathe, because on the lathe you're always doing stuff with calipers that you probably wouldn't want to do to a really expensive set. Anyway, I'm gonna make a light pass here, and then I'll quit filming and finish the bore up. It takes a couple hands to do this right, so let's take I need to take 135 thousandths out from where I'm at, so I think we'll take Let's just take 25 thousandths and see what happens to it. That might be a little heavier than what I want to take. Lube in here. Oh yeah, no worries. No singing or nothing. So what I'm watching is this. I'm not even looking up there. I'm looking down here because I don't want to crash my tool. You see, it's auto feeding. I'm just holding this lever so I can shut it off. So I'm going to watch this. There. And then I'm going to manually bring it over to 0. Bam. And I'll just back it out. I'll just be repeating that process until I get my bore where I want it. All right, got her bored to size there. Now I'm going to chamfer those inside and outside of that thing, get those razor edges off there, and setting this thing up to do metric threads is kind of something I don't do very often. I know this thing's capable of doing it. I'm gonna have to study this chart a little bit and figure out how to get it set up and see if I can get it. And then the second thing is gonna be is the depth of the threads. I'm gonna have to look that up in a book or something. I've got a machinery's handbook I'm gonna look into, because I can't take that part off and check it. Normally I would just keep cutting the depth of the threads until whatever I wanted to fit in the threads. But if it was an outside thread, I've got wires, and I've actually got a couple thread mics where I can measure the depth of the thread. But on the inside, I do not have a way to measure that. So I'm just gonna have to do some math and figure out, when my compound is set at an angle here, how deep to cut the thread to get the end result that I want. And I may mess that up. We'll see here. Okay, so I've studied on this a little bit. I hope I'm right. So this is our metric chart. We're wanting a 1.5 thread pitch. So we want H, which is our top gear, to be 48 teeth. That's the gear that I got in it now. And then our hand lever should be A, F, and 8. So this one here, F, is pulled that way. And then A is up that way. And then the gear selector here to be 8. So I think I'm set up. Oh yeah, now the other thing too is G. For metric, I pull my G out. And G is the spur gear that's in here. And I pulled it out a while ago, so we're out on G. So I think that's right. That's it. Now let me get it set up for threading on the tool end. All right, so I remembered something here. In order to cut left-handed threads, I have to start on the inside and cut to the outside, which is opposite of the way you would normally cut threads, or at least the way I do it. So I scrounged around. I bought this a long time ago. I never used it. It's an internal grooving tool, and I was going to use it to cut like O-ring grooves. It's not going to focus on there, but yeah, there we go. Anyway, I went in. It's hard to see, but I went in right back here and I cut a relief in the very back there. That way my threading tool has a pocket to start in, so I won't snap my threading tool off when I enter, and then I cut from inside to outside. Okay, so there's a lot going on here to make a left-handed thread on this thing. Because it's metric, once I engage my threading dial here, I can't disengage it. So I have to run the spindle in and out power-wise. Well, my brake on this lathe is not very good, so that's kind of a heart check every time I get close to the shoulder on this end, trying to stop it within 20 thousandths of this dial or not, of 0, to keep me from crashing it. I've already made one light pass in here, and I don't know if you can see. Let's see if I can get a little light here. Y'all can see that or not, right there maybe. You can kind of see the thread my scratch pass, and then if I take my gauge, stick in here, y'all can't see that. Anyway, you have to take my word for it. It looks like it's the right thread pitch. And that's just testing that I've got all my gears and everything set up over there. So I'm gonna make a few more passes here. I can't film this because, man, it takes, I need 3 hands to do it anyway, but we'll see how it goes. All right, finished up with the threading on that part. That material did not cut the greatest, smoothest threads in the world, but they'll work if they'll fit. Now here's the scary part. Without having a way to carry that over there and put it on there, it was all math and on my part, because you put your compound at a 30-degree angle, so you have to kind of calculate your depth off that. So here's the moment of truth. Wait a minute. I think it's gonna work. I don't want to screw it on there just too far yet till I get a wire brush in here and kind of deburr those threads, but that's actually a pretty good fit. So I'll call that a success. Next I will go in here and I'll probably just bandsaw this off, put it back in the lathe facing the other way, dress up this front face, and then drill and tap this front for a pusher bolt to push it off there. But yeah, that's my first time of ever cutting left-handed metric internal threads. Alright, so I bandsawed that off and fixing to start my hole on this side. Alright, so in keeping with the metric theme, I grabbed my junk bolt bin there, pulled out this 16mm bolt. I'm going to cheat, run a tap through it, drill this. Alright, got her tapped. If you don't have a set of stair tap handles, find you some. I bought my set, I pieced them together over the years from eBay and flea markets, but there's very seldom you get a tool that's made completely properly and you have no complaints at all, and that's one of them right there. Stair tap handle. worth whatever they want to charge for them. Once you use one of these, you'll never pick up another one. Well, call that a success. Popped it right off there. Now, I've spent 3 or 4 hours here making something that I could have bought for $16. Wasted half a day. Now I still gotta put this thing together, so.